Hi everyone, and welcome to this video on how to multiply and divide algebraic fractions. So we've looked at simplifying, we've looked at adding and subtracting. Now it's time to do multiplying and dividing. And let's go back, like we did on all the other videos, to some really simple basic forms that hopefully you already understand. So for example, what's half of a half? You notice I said of instead of multiplying because we can. That basically means exactly the same thing. So if you see a multiply, you can use the word of. Often makes fraction questions a lot easier. Half of a half, we know, is 1/4. So then we begin to look at patterns. We say, well, how do we get the 1? How do we get the 4? And it's like, crikey, this is easy. You just times the tops and you just times the bottoms. You see that? It's that easy. That is how you multiply fractions. So if we bung in loads of algebra, we can do that. But if we get answers that are really big numbers, we can often simplify them. And that's the whole trick with this, is can we simplify early to make our life easy? Look at this next one. Okay, the first bit, 3 times 10, that's fine, that's 30. I'm just going to pop that over here, 30. And 5 times 21, it's not the greatest, but it's 105. Now I can tell straight away, because these both end at, well, both of them, they don't, that's a lie, but one ends in a 0, one ends in a 5. That means they're both in the 5 times table. So I can instantly cancel this down. But it's often a lot harder at the end, so you should have been encouraged to look at how you can cancel. Now, the wonderful thing about multiplication is you can do them in any order. For example, we know we're going to times the tops, and we know we're going to times the bottoms. Well, I could do it like this. I could, instead of doing, 5 times 21 at the bottom, I could write 21 times 5. It's the same thing, isn't it? And because I went from this form to this form, if I then went back out, I would have 3 over 21 times 10 over 5. I would never normally do this, but I'm just doing this to explain something. So 3 over 5, I can't simplify that. There's no factor of 3, no common factor of 3 and 5 for me to divide by. Same with 10 and 21. But when I write it this way round, you can see these are both in the 3's and these are both in the 5's. So I could simplify these. So what I'm trying to get you to understand is too many teachers tell you tricks. I'm not a fan of tricks, but I want you to understand that when you're multiplying, any numerator and any denominator you can cancel. So you can cancel vertically like you normally would, here and here, or we look across, so any numerator with any denominator. Okay, so let me just get rid of all of this and I'll show you what I would like you to do. Probably should have used a bigger rubber. We're nearly there. There we go. Okay, so can I cancel the 3 with the 5? No, I can't, but I can see that these are both in the 3 times table. So if I divide both by 3, I get 1 there and a 7 here. Now, the 5 and the 10, they're both in the 5 times table. So if I divide both by 5, I get 1 and 2. The numbers are far simpler. 1 times 2 is 2, 1 times 7 is 7. So these two are equivalent. But it's much easier to cancel at the start than it would be at the end. I just want to make another point before I go on to the algebra ones. So they can't cancel, and nor can they. Okay, I can't cancel anything. But if I had a third one, for example, let's put a 9 there and a 16 here. I can cancel this numerator with this denominator, this one, and it works here. They're both in the 3's. Let's have a look at this 7. So 7 I can't cancel with any, so I can't do anything. The 16 I can cancel with this 8. So that'd be 1 and that would be 2. That's all the cancelling I can do for this question. Sometimes there isn't any, but it's really important to understand any numerator with any denominator. So let's move on. Okay, here we go. Here comes the algebra. So xy just means x times y. And you can clearly see we can't cancel these down. But is there something I could divide the top and the bottom by here? Well, yes, there is. I could divide the top by an x and the bottom by an x. And there are no y's on the denominator at all, so I can't cancel any y's. But if we look at the 9 and the 15, they're both in the 3 times table, so I can divide them both by 3. Now I've done all the cancelling I can. I've got 5 times y, so 5y, and I've got 3 times x, and then you have it. Done. It's as simple as that. So it's not just numbers we can divide by, it's also letters, but you should be used to that with the simplifying fractions. Okay, so let's look at this numerator. Can I cancel anything here? So there's no a's on the bottom, there's no b's on the bottom, and 4 and 21 don't share any common factors, so that is as simple as it would go. So let's have a look across. So, look, I've got the 21 and the 14, so I can go 2, they're both in the 7 times table, and 3. Oh look, I've got a's at the top, so there's a times a here and an a. So if I divide top and bottom by an a, this one's going to go, it's technically a 1 there, and I'm just going to be left with an a. And the b's, if I divide top and bottom by b, they're going to go, but just get in the habit of putting 1s, because if you get rid of everything, just please remember there is a 1 there. Okay, right, let's have a look. So the 4 and the 8, they cancel, they're both in the 4 times table, so let's divide top and bottom by 4. And we've got some c's here as well. We can divide top and bottom by a c. So it's a lot of looking around here, but let's see what we've got. We've got 3 times an a times a 1, so that is 3a. I'm just going to write it out again just because it's easy to make a mistake here. So I've got 2 times 1 times d. I've got 2 d's. Now here, if you don't put 1s, people think there's nothing to write, but when we're cancelling, things don't just disappear, it's just dividing by 1 or timesing by 1, so they kind of look like they have. So there is a 1 there, and I've got 2 times 1 times 1, which is 2. Now I didn't spot that I could do that earlier, so you can see I can divide top and bottom by 2 here. So they're 1s. So I essentially have 3a times d, so I've got 3ad, and I've got 1 times 1, which is 1, so I'm not going to write anything. So that pretty ugly looking fraction simplified to something quite simple. Okay, step it up a little bit more. So hopefully you can appreciate these have been factorized. So this is now a multiplication problem. Remember, when we have an addition or subtraction problem, we factorize, we turn it into multiplication, and that's really useful for simplifying fractions. So nothing can cancel here, like this bracket. So if you imagine before and simplifying, you just had that part. Now you've got an additional part next to it. And for this bit in the purple box, there's nothing you can divide by, is there, to make it smaller. So we have to look across to the other one. I'm just going to get rid of that box now. So is there any x plus 5s on the bottom? Oh yes, there is. So let's divide top and bottom by x plus 5. Now let's have a look at the bottom of this one. I've got x plus 2s here, so I can divide top and bottom by x plus 2s. Is there anything else I can cancel? No. So we're finished. We just have to times the tops. So we have x minus 1, x plus 3. And if we times the bottoms, we just have an x times 1 is just an x. And you can go ahead and expand that if you want to, but there really is no need. So we've taken that big problem and we've simplified it as far as it will go. Now, next one. So this is definitely harder because we have to do the factorizing ourselves. Where should we start? Well, I can see some dots, so let's do that. So x plus 2, x minus 2. The denominator on this one catches a lot of people out, but it's a single bracket problem because there's an x common to both. As soon as you have a common factor, it's a single bracket. So we have x plus 3. The next one, there's nothing common to all terms, so it's a 2 bracket factorizing problem. So x and x, factors of 3 that make 1, well it's a prime number, so that's a pretty easy one. And again, there's a highest common factor here, so let's take the highest common factor out and see what we need to go in the middle. Okay, so none of these cancel, so we have to look diagonally. Right, I can cancel the x minus 2's. So put 1s, getting a good habit. The x plus 3's, I can cancel those. That's fine. And that's it. So what have we got when we times the tops? We have x plus 2, x plus 1, and x squared. If I did expand this, I just want to just point something out to you. Don't cross off the x squareds. If you divided top and bottom by x squared, you'd have this. Right? If you divide the top by x squared, you would have, oh, not that, you wouldn't have that. So basically that's what it would look like. It's not right, yeah. You wouldn't try and simplify further that. And you've got to appreciate that there's no common factors there and there's no common factors here. So don't try and make things smaller because you think they should. It's all to do with factors. Okay, worst case scenario. We've got the AC method possibly here. Well, it's definitely harder to factorize when we have, oh, what's happening? My pen's not working. Here we go. It's definitely harder to factorize when this is not a 1. And we've got 2 of them. So this is definitely the worst case scenario. Okay, well, if this was a simplifying question, I would say work with the bottom first because it's easiest, dots. So let's just go ahead and do some things that we can see that are easy here. I'm not really talking you through those. I expect you to be able to do them by now. And we can see that there's going to be some sort of cancelling here. Okay, now if it was a simplifying problem, I would expect one of these brackets to feature up here. So it's kind of nice, but for this reason, I am expecting there to be some cancelling here. They don't normally give you questions like this with nothing that can cancel. So I'm going to start with this one because 3, there is only one combination it could possibly be to get 3x squared, and that is 3x and x because it's prime. If I started with this one, I've got a much harder job because it could be 6x and x or 3x and 2x. This has only one combination, 1 and 7 or 7 and 1, so 2 combinations really, but this has 3, 2 and 2, 1 and 4, 4 and 1. Okay, now if I put a 4 there and a 1, the only reason I'm doing that is because I can see 11 and I know that's 12, so it's pretty close. So 3 times 4 is 12, so that'd be minus 12, and if I add 1, x, I get it. So that's it, it's factorised. And if you can't see it as quick as I did, I got lucky to be honest, you can just put the 1 there and the 4 there and just play around with the outers and the inners. Remember, the outers and the inners, the sum of the outers and the inners make the middle term here, the b coefficient. Okay, so the great thing is now, well, it doesn't really help too much. So we just have to, I'm going to make a commitment now. So normally it's the middle factor pairs. So I'm going to go for 3x and I'm going to see if this bracket cancels. So if I'm hoping that this is the bracket that cancels, if that's 3x, that has to be 2 to make 6. Can't be anything else. That means that would have to be a 1 if I'm going to cancel that bracket. And because we're trying to make a 7, 1 times 7 is 7. So does that make, because I might rub this out, does that make 29x? So we've got 21 and 2. So no, that does not make it. Now my only problem is I think I might have written this question down ever so slightly wrong now, because 21 is going to get me the largest it could be. Let me just, I'm just going to pause the video quickly here and just have a play because I might have written the question down wrong. 1 second. Yeah, I definitely have written this wrong. I've just looked at all the factors of 42 and none of them make 29, but it's clearly I was trying to set this up to make this one. So let's just change that 9 to a 3 and then it'll work. If I didn't change it, guys, this question wouldn't cancel, and they're never ever going to give you that. So you can see here, just get rid of that. There's 21 and there's 2 and there's 23. Okay, so the first one I tried, I got lucky there, but you can see that these are going to cancel. Oops, didn't mean to actually rub it out. So they're going to cancel. Is there anything else that can cancel? No, there's nothing else. So let's just times them. So we've got x times x minus 4 on the tops. And we've got these two brackets, so let's just write them, x minus 3, 2x plus 7. And you can go ahead and expand it, but there really is no point. Okay, it's time for some dividing. Now if you can multiply, you can divide. Keep, change, flip. Keep, change, flip. That's how you've been taught to divide. since primary school really. So we keep, we change to a times, and we flip. And then it's times now, okay? So you just turn divide into times, so everything I've just been telling you is still true. So 2ab divided by c, that can't cancel, but I can cancel this numerator with this denominator. I can do the same with the c's, so if I divide that by c and that by a c, and what do we end up with? 2ac's over a d. Clearly nothing can cancel there. Same with this one. Okay, we need to factorize here. So always factorize. Because this is subtraction, we can't begin this process until we have multiplication everywhere. It's only the factor. We need to see factors so we can divide top and bottom by the same factor. I really hope that message is coming across nice and clear to you. So, so I factorized that one. There's no factorizing that can take place here. So what I'm going to do is keep, but I've rewritten it, change, and then flip. Okay, so I can see that these x's, they do cancel, okay, but I could also cancel the x there. So I have a choice. So I'm more inclined to cancel that way. I think there might be, you might find it a bit harder the other way, but I could have just crossed those two x's off and just left that one. It doesn't make any difference, to be honest. And let's just put 1s there for good measure, because we're dividing top and bottom by x. Dividing anything by itself is a 1. Okay, the 4 and the 6, they share a factor of 2, so let's divide both by 2, and we have that. Now, the x minus 3s, that's a factor of top and bottom, so we can divide that. Let's put 1s, and that's it. So we've got x times 1 times 3 times 1 times y, so that's 3xy. And on the bottom we've got 2 times 1 times 1, which is 2. I think that's it. Yeah, that is. So if you can multiply, you can also divide. Just remember to keep, change, flip. If there is additional subtraction in any parts of the fraction, you need to turn it into multiplication by factorizing. That's the message. Okay, if you've understood that, it's just now time to go away and practice, and best of luck.